Welcome back. This is an Aleks homework video on calculating and using the molar mass of elements. Very important section, a section you will be doing this for every remaining chapter in the book. So it's important to try to learn this well. The molar mass, or the mass in grams of 1 mole of any element or any compound, is simply its atomic mass from the periodic table, expressed in grams. The periodic table is expressed in daltons, and a daltons is simply just atomic mass units. If you remember atomic mass units, it's just the average between the proton and the neutron. So how many nucleons, I think it's called, is a proton and a neutron, anything that's in the nucleus. How many nucleons is it in that material? And that's how much it weighs. So the atomic mass on the periodic table is in AMUs, atomic mass units, but if you express it in grams, so for instance, you simply look up the mass of an element, and whatever that mass is on the periodic table, if you express that in grams, that's how much 1 mole of that material weighs. That's why a mole is so useful, because you can convert between one material and another and know exactly how many you have and know exactly how much that it should weigh. It's a total, pivotal, total important concept in chemistry. So this is saying a chemist weighed out 55.2 grams potassium. So we need to go to the periodic table. You should always have a periodic table when you're doing your homework. Calculate the number of moles of potassium she weighs out. So we're changing 55.2 grams of potassium into moles of potassium. All right, so to do that, you're going to need a fraction where the top and the bottom equals the same number, and that is derived from the periodic table. Okay, I'll show you. So start with what you're given, 55.2 grams. So 55.2 grams. And then you're going to go to the periodic table and find out what is the atomic mass of potassium. So potassium, number 19, is 39.0983. Okay, grams in 1 mole. Okay, grams per mole. So this is the atomic mass that you get from the periodic table. We're in grams, we divide by grams, we get moles. If you have moles, divide by moles, you'll get grams. So you can change back and forth between grams and moles. So 55.2 divided by, get out my phone just a minute. All right, so 55.2 divided by 39.0983, okay, gives you 1.4118269 grams cancel, moles. Okay, now we've been given 55.2, and 55.2 is 3 significant digits. So I need to round 1.14 blah 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 into 3 significant digits. So all these are non-zeros, so I would just pick the first 3, and you have 1.41 moles of potassium. And that's how you do the problem. Thank you.